excited to have here with me today Mary Beth Hudson. She is the Executive Director of the Smart Factory Institute and also a former manufacturing executive for Walker Chemical Company. Also joining us by Zoom is Dr. Chris Cunningham, who serves as the Director of the IO Psych graduate program at the University of Tennessee, Chattanooga. The Smart Factory Institute has commissioned a research report by Dr. Cunningham and Scott Myers, a graduate student in the program, in which we'll be discussing today. Before we get started, though, I'm going to ask you, if you have not already registered in the Peak Workforce Training Center, that you please do so. Registration is free and easy. Simply use the URL that is provided on the screen here, or you can scan either the barcode with the camera on your phone, and it will take you directly to the registration page. Whether you're a manufacturer or not, registering helps us in determining important information regarding industry's needs and interest. So you can see there the QR code for both the Apple Store and the Google Play. So let's go ahead and get started. In 2020, manufacturing accounted for $2.3 trillion in total output, contributing to 10.9% of total output to the U.S. economy. This would be the largest economy in the world, higher than Italy, Brazil, Canada, Russia, and South Korea. There are also almost 250,000 manufacturers in the United States, with almost 75% of them having less than 20 employees. So when we're talking about small and medium-sized manufacturers, the impact that they have in the manufacturing industry is enormous. Also, as we take a look at small and medium-sized versus large size, almost 90% of them have less than 100 employees. Manufacturing employs about 8.5% of the total workforce, with 13.9 million employees, and they have an annual average total compensation of $88,000. Additionally, manufacturing has the highest multiplier effect of any economy sector, and for every dollar spent in manufacturing, another $2.79 is added to the economy, and for every one worker in manufacturing, there are another 5 employees that are hired elsewhere. As we guide down into the U.S. and Southeast region, the automotive sector is the fourth largest manufacturing contributor to the overall American GDP, and in 2020 contributed $157 billion. But over the past 20 years, there's been a 16.7% employment increase. And here in the Southeast, it's playing even a larger role. Recently, there's been more than $26 billion in electric vehicle investment announcements, and automotive is the #1 manufacturing sector in Alabama, Tennessee, Kentucky, and South Carolina. We're going to ask you all to participate in a poll, and what we're asking for you, manufacturers, and if you're not a manufacturer, please go ahead and click other. But today we're looking for what industry best describes your company. And so you can choose chemicals, fabricated metal products, food, beverage, and tobacco products, machinery, miscellaneous durable goods, motor vehicle parts, paper, plastics and rubber products, or other. Okay, we still have a few more coming in, and let's share those results. And it looks like that you can see on the screen there that our results are showing, and that we have a little bit of everything here. I can't see all the results, so let's go ahead. Thank you very much. This chart here, this graph shows the trends of manufacturing output versus headcount over the past 20 years. The darker line is the manufacturing output. The light blue line is headcount. And it's estimated over the next 10 years that there is going to be a decrease of 3.5% in overall manufacturing employees. This is due to high rates of separation and lower than necessary numbers of interested, available, and skilled talent to fill the positions. And if you're in manufacturing, this is not a huge surprise for you. But if you take a look at that dark line, over the last 20 years, you've seen an increase of production output, and it is projected that over those same 10 years, there's going to be a industry output growth of 16.4%. So that's a 16.4% growth in manufacturing output. At the same time, we're going to have a 3.5% reduction in manufacturing employees. Which brings us to a labor management challenge that faces all manufacturers. If you're a manufacturer and you're tuning in to us today, I'm not telling you anything new, but I am providing you some details and some numbers to back up what you're feeling. In 2020 and in 2021, although all industries and individuals were impacted by the COVID-19 pandemic, the data indicate that the manufacturing industry was fairly stable. And I know you're thinking, what? But it was very stable as compared to other industries, and it showed signs of earlier recovery than many other industries. And so you can see here in this chart the total separation rates by percent by industry, and you can see manufacturing versus all industries in total. So whether you're examining current trends or historical data, manufacturing is experiencing and will likely continue to experience a variety of serious management concerns. It is also important to note that the overall separation rates within manufacturing are consistently below the overall rates. An implication of this is that although manufacturing faces critical issues with labor management that require critical consideration, it is a more stable sector of employment compared to other industries. And Dr. Cunningham, I wanted to turn it over to you to see if you wanted to make any comments at this time.
Yeah, I appreciate that, Denise. I think the way you're presenting it is right on the money here. And I think that it's also worth just highlighting that these challenges right now with turnover and retention are very universal. They're being felt in every sector. And as you pointed out, that when you compare manufacturing to those other sectors, you see actually a relatively stable trend here. The thing that has us a little concerned after putting together this report is that the manufacturing industry itself is also struggling with some identity and brand concerns, as well as this shortage in skilled talent, which you alluded to, and I know we're going to speak about a little bit more here in a minute. So although we've seen some good stability up to this point, we really do think that now is one of those critical juncture points where a lot of attention needs to be spent on identifying the new talent, retaining the existing talent, and generally raising the overall skill level for that workforce. So these are some themes that we'll pick up on as we go a little further in here today.
Very good, thank you. And that leads right into our next information that we have here around needing that pipeline of qualified workers. And you can see that 89% of small manufacturers cannot fill all of their job openings. Usually a production job or production position is taking more than 3 months to fill, and that less than half of the 4.6 million open manufacturing jobs will actually be filled over the next decade. And the combination of the decreasing workforce and the increasing overall demands highlights the or the critical need for widespread workforce development efforts to prepare the existing and the emerging workforce for the Industry 4.0 technologies and processes. So when we take a look at workforce, we're taking a look at what we call the existing or the incumbent workforce, as well as the emergent workforce. And those two different workforces are different, and they have different needs for preparing for Industry 4.0. This is only going to be possible with more widespread adoption of Industry 4.0 technologies and practices that's going to really improve the way that manufacturing is efficiently being done. And we're going to have a blended approach of human-machine augmented work arrangements supported by these advanced technologies. So when we're looking at production efficiency and how that's going to support our growth, there's a variety of Industry 4.0 technology developments that are expected to positively impact the manufacturing process and ultimately create a more agile and flexible production system, helping manufacturers close this gap between rising output and declining employees. And so some of the things that, 3 areas that we're really focused on is one is reliable supply chain and being able to shorten and really secure a more reliable supply chain. Or you may have been hearing quite often now about near sourcing. A lot of this has been accelerated by COVID-19. This will have a very positive impact on small and medium-sized manufacturers because they are typically the supply chain to the larger manufacturers. And so as those larger manufacturers are really trying to near source and secure that, small and medium-sized manufacturers are going to have a lot of growth in their over the next 10 years. The second one is sustainable production. This is really important around energy efficiency, and it's going to save cost and resources. And the third one is advanced manufacturing technologies. And this is where we're deploying new technologies to reduce human error, which will improve quality, reduce downtime, which will improve efficiencies, and improve our yield, which has this increased focus, efficiency, all of these leading to lower production costs, which is very important for our manufacturers. So at this point, I'm going to turn it over to Mary Beth.
And Industry 4.0 helps manufacturers become more competitive in the marketplace. You see a lot of words on this slide, a lot of buzzwords, but basically what we're seeing is customers are demanding new products sooner. They want it to be cheaper, and they expect the products that they have to be more sustainable, using less resources than in the past. Industry 4.0 focuses on automation, connectivity, and data. And the end result is an increased efficiency and productivity, like Denise was talking about, which leads to a better return on investment, while at the same time guaranteeing a high-end product quality. Uh-oh. Excuse, it just went way back, excuse me. There. Industry 4.0 is the fourth industrial revolution since the late 1700s. The industrial revolutions of the past were essentially about the advancement of technology, but Industry 4.0 is more about the evolution of technology and its impact on our everyday lives. It refers to the way computers, data, and automation are evolving to change the way work happens, and in particular, the way manufacturing work happens. It takes technology to the next evolution by blurring the lines between the digital and the physical worlds. Dr. Cunningham, would you like to say anything at this point also about Industry 5.0?
Yeah, I would. And if it's all right, I'd also like to highlight that these transitions were not just about technology, but also had huge implications for the worker experience and the general dynamics that revolved around workers. So just real quickly, in Industry 1.0, there was a huge transition here in how many workers changed from being producers, direct producers themselves, to being operators of machines that then produce the products. And as you carry that over to Industry 2.0, there then developed new ways of communicating and managing these individual operators in teams and large systems that we now refer to as the manufacturing organizations. And this was that time period during Industry 2.0 when there were some grand experiments in terms of the management of human talent. This is when Taylorism and scientific management evolved, for instance, and other styles like that. As they headed into Industry 3.0, there were huge developments around technology integration and a lot of transitions in how these different machines and systems functioned, which required tremendous investments in training and developing that workforce in new ways that had not really been heard of before. So when we get to today's state of Industry 4.0, and as we even move beyond this, what we're seeing is all of these developments continue to roll like a giant, snowball, and we're continuing to push these workers and their managers and these organizational systems further, faster, and in a direction of more efficient and lean production. The Industry 5.0 that Mary Beth just alluded to is another kind of forecasted state that is likely to develop in the coming decades. And we see this really as likely to be more of an incremental change than what we're seeing with Industry 4.0. At the Industry 5.0 stage, there's really going to be an opportunity with the digitalization that's happening now, and also the large amount of data that's being generated and collected and analyzed. The Industry 5.0 will bring the opportunity to re-engage human touch into the process and create opportunities for more mass customization than has been possible to this point. But just so we're clear, our focus really right now is on Industry 4.0 and the ways that this impacts the manufacturing processes, but also the workforce dynamics.
Okay, thank you. So the smart factory of the future includes advanced connectivity, data-driven intelligence, human-machine integration, and advanced production methods. But you can see the smart workers and the smart managers are at the core of Industry 4.0. Each pillar changes how work is designed and conducted. And in the next few slides, we're going to explore more in each of them in more detail. So, advanced connectivity has already had an impact on our personal lives. We can control our lights remotely, our thermostats, we can open our garage doors, we can even talk to people that are on our front doorsteps through our smart doorbells when we're not at home. This same technology leads to interconnected manufacturing environments, and it makes it possible for real-time production monitoring, enabling a more efficient supply chain, everything from planning your raw material deliveries all the way through production, all the way to delivery of the products at the customer. Dr. Cunningham, would you like to add anything?
I think your summary here is really good. And I think the most important thing to emphasize about this set of technological advancements is the point that you led with, which is that a lot of these technologies we're already living with today. So there are definitely some advancements that might seem a little scary and might seem like they're out of reach, especially for smaller organizations. But the reality is that we're already utilizing much of this technology. And so the challenge as we transition more into this Industry 4.0 period is figuring out ways that we can leverage these technologies for the benefit of the organization and also for the benefit of the worker. And in the report, we discussed some other opportunities here for these technologies to be useful in helping guide worker safety, to help you track worker development. There's so many opportunities that these technologies present. So I think this is definitely one of the exciting prongs to this area of development.
Absolutely, absolutely. Another aspect, sorry. Yeah, sorry about that. Another aspect is data-driven intelligence. Data-driven intelligence includes artificial intelligence, machine learning, and big data and analytics. These are all terms that we have heard of. But the bottom line is data generated by connected systems can be used to improve production processes. The connected devices coupled with data analytics will facilitate better informed, just-in-time decisions. Dr. Cunningham, would you like to add anything?
Yeah, absolutely. I mean, this is one of those areas where most people probably are not comfortable with the technologies because this is some pretty advanced stuff going on here. And I'll say even just about 2 or 3 weeks ago, the data analytics fields were just reclassified as STEM fields, which is really important for the way that we approach education at the high school and college level. It's also important for our ability to attract new talent to this country from other areas where they may have more advancements in the development in these skill sets. But one thing that's really important is that although data analytics and artificial intelligence and machine learning may require very specialized skills, the good news is that there has been a tremendous growth in the learning opportunities along these lines. So you may not have a lot of existing people in your workforces that already have these areas of expertise, but the ability to develop this has never been better. And that's becoming something that's so readily available that we do believe it'll be possible to both upskill the existing workforce and start to attract new talent that's already developing these skills.
Yeah, very good. Okay, and then human-machine integration is the next pillar. The connectivity that we just talked about facilitates unique opportunities for human-machine collaboration. Augmented reality and virtual reality tools can allow simulation and optimization, leading to better decision making and execution. An example is analytics can predict equipment failures and even automatically trigger maintenance requests before a piece of equipment shuts down. And then AR tools can help guide workers to make the repairs necessary to get that piece of equipment back up to optimal operation. This saves a lot of time, it reduces downtime, increases reliability, and ultimately increases the output in manufacturing. Collaborative robots take over repetitive, physically demanding work, allowing workers to perform more complex operations. So overall, advanced technologies increase the productivity of humans. Dr. Cunningham, would you like to add a few comments?
Yeah, sure. I mean, I think the summary you gave is really great. And I also would just stress here that, from my own perspective as an industrial and organizational psychologist, these integrations also present some tremendous opportunities for not only how we train and develop workers, but also how we recruit and how we screen and select them. There's just so many amazing opportunities that this technology presents us now to help get workers up to speed before they actually enter the full production process. And there's also some interesting opportunities here to rethink, the relationship that workers have with the work that they're doing. So this is a huge area for further exploration and development, but I think also one of the most exciting areas that Industry 4.0 brings.
Very good. Hit it once. So advanced production methods improve safety, quality, and efficiency of production processes. Additive manufacturing and integrated systems can allow for more rapid prototyping and faster, more efficient designs. We're all familiar with 3D printing as a prime example of additive manufacturing and some of the advanced production methods. These methods facilitate mass customization of products in response to the ever-changing needs of the end customers. Again, Dr. Cunningham?
Yeah, from a workforce angle, these technologies are some of the areas where we're likely to see the need for some of the most focused and more advanced training efforts, because some of these technologies really are going to be very new, especially for the existing workforce. And then for the emerging workforce, just making sure that students have access to learning about some of these technologies. And I know this is really one of the priority areas for the Smart Factory Institute.
Okay. So at this point, we're going to conduct another poll and ask the audience, what technologies does your organization plan to implement in the next year? And I'd ask, check all that apply. We have advanced connectivity, data-driven intelligence, human-machine integration, advanced production processes, or you may not have any plans to implement Industry 4.0 technologies in the upcoming year. So let's see where the poll is taking us. We're still getting some coming in. It's interesting that quite a few of our respondents are saying that they don't have any plans to implement Industry 4.0 technologies this year. And I know that COVID-19 has a top priority in a lot of our work environments. But outside of that, advanced connectivity and data-driven intelligence are really the top two categories of Industry 4.0 technologies that people have plans to implement in the upcoming years. And that makes sense because those provide the foundation for the other technologies of human-machine integration and advanced production processes. Okay. So
we have a question from the audience, and that question is will Industry 5.0 lead to more customized products?
Will well, certainly, and I think Dr. Cunningham, you have quite a bit of evaluation that you've done on Industry 5.0 and the impacts.
Yeah, I was briefly responding to that in the chat. That is really the most educated prediction right now about where this all leads. And I mean, I think everybody here probably has enough historical perspective to understand that, there was mass production was really one of the outgrowths in the earlier industrial revolutions to try to create profit through volume and standardized volume that was could be controlled and could allow you to maintain quality. And now what we're seeing though is that as the technology continues to develop and as more and more data are gathered on how end users are using their products and what kinds of challenges they need or where these products tend to struggle or maybe not fit the needs of different consumer groups, there's an opportunity now for the manufacturers to learn from those data and to start to tweak and adjust and offer other options. Now, this has already been happening. I mean, we have examples of manufacturers that are already doing sort of batch customization, where they'll produce maybe 3 to 5 different versions of a particular product. We all see this very often in the auto industry, but you also see it in furniture manufacturing and other areas. But the prediction right now is that as the advancement of these technologies grows and there's more and more sensors and other forms of connectivity that are feeding data back to the organizations that are doing the production, there'll be an opportunity to start creating products that didn't start with an idea, but that actually started with a user need. And it's hard to explain this, but just try to picture this for a minute. Instead of you trying to anticipate what customers are going to want or going to need, the customers are actually going to tell you through their usage patterns, through the support calls that they're making, for instance, and you'll be able to now start to adjust what you're producing and putting out there as a result. Now, some of the bigger organizations are already starting to do this, but the fact that this power would be in the hands of even some of the smaller and medium-sized companies is one of the big excitements about where this is all leading. So again, to the question that was asked, by the time we get to Industry 5.0, is mass customization likely to be a reality? That is the most educated prediction right now, that's exactly where this technology is pushing us.
Okay, great. Okay, so we've talked a lot about the technology advancements associated with Industry 4.0 and even Industry 5.0. However, most organizations overlook the impact to the workforce. And there's been very little work so far that has been done to understand the impact of Industry 4.0 on the worker. Again, look at this model. People are at the core of these technology advancements. We already have a shortage of skilled workers to fill today's manufacturing jobs. This problem only gets worse if we don't consider the workforce of the future. Successful implementation of Industry 4.0 is only possible if our workforce is equipped for these technology changes.
Coming through that both you and Dr. Cunningham could take a crack at, and that is, what is the role of K through 12 education? And this would be towards the emergent workforce.
So I'll start and then hand it over to you, Dr. Cunningham, because I know you have done a lot of evaluation in this area. But from my perspective, we really need to introduce these career opportunities at a very early age. High school's too late, even middle school is late. A lot of the students are deciding what career interests they have. They may not even realize they're deciding it when they're in elementary school. So we need to be able to introduce these concepts at an earlier age, and also get the parents involved in realizing that these are really great careers that their children can have in the future. Dr. Cunningham, your thoughts?
Yeah, no, those are good observations. And I know that this was something I kind of mentioned earlier, is that in addition to a shortage of talent, there's also kind of this unfortunate lingering brand or identity issue that a lot of manufacturing areas struggle with. And it's this idea that manufacturing is some sort of like, dirty or not advanced work, which is really not the truth, especially as we transition into these higher technology forms. And So helping the parents, helping the schools, helping the guidance counselors, helping communities understand what the current reality of manufacturing is and where it's heading, that's super important. The other thing that's really important to stress is that education is right at the core of this. And it's simply impossible to develop a workforce that will be suited and equipped to handle the challenges of this high technology form manufacturing without making sure that there are very focused educational opportunities all the way up, not just K through 12, but even beyond that a little bit, to help folks develop these advanced skill sets. One other thing that I think is really important to just mention here, and it's something we'll probably pick up on in some future sessions, is that it's also that time when manufacturing might need to start broadening its net as it thinks about recruiting and attracting talent, and realizing that there may be serious talent that needs to now be brought in from more highly educated fields in advanced engineering, for instance, or computer science, where we generally maybe haven't been tapping these fields because we didn't really think that necessarily getting an advanced college or graduate degree was necessarily critical for maybe some of the jobs that we needed filled. Well, now as the technology advances more and more, there's going to be a need to have folks that have more experience with that and have had the additional training necessary. And some of that training can't be met with just the K through 12 education. I hope that makes sense.
Yeah, good. Okay. So again, Industry 4.0 changes the nature of work in manufacturing. We'll have new, efficient, connected, data-driven ways of working. Our work becomes more complex and strategic, and that changes the way that the worker performs their everyday job. So consideration must be made to the workforce to make sure that they are ready.
Great. We have another question that has come in, and that is standards. Training with objective measurement for manufacturing workers has lowered significantly to keep employees showing up without the stress of new learning. Can this be overcome? Schools have the same lowering of measurable standards of achievement. That might be a good question for you, Dr. Cunningham.
I think so.
I'm smiling and laughing only because I am also a professor of undergraduates and graduate students. And so I feel this pain daily, trust me. The lowering of standards has been a challenge, and it is often done in an effort to meet candidates and students where they are, so we don't create barriers to their success and achievement. We are, I think, absolutely within our rights to question whether that approach makes sense going forward, especially because we're talking about having to raise the bar in a way in terms of what our individuals need to be able to do. Thing about education is you do have to understand where your learning people happen to be. You have to understand their target, their baseline. And we have to develop strategies for connecting with them and helping them understand, okay, here's where you are now, and here's where we need to get you. But what often gets lost in a lot of these workforce training efforts is that we talk a lot about the gap, but we don't always tap into the reason that we need to address that gap. And we don't often develop the training with enough emphasis on keeping people engaged and motivated in that learning. So as we talk about doing some much more advanced forms of training on our existing workforce, and as we talk about trying to recruit new talent that's already going through this educational pipeline, I do think this is an area where we need to spend a lot more time discussing opportunities, helping people understand that working in manufacturing is not just necessarily a clock in, clock out job, but there is a meaning and a purpose to what you're doing. Tapping into what motivates people to get out of bed in the morning so that we understand how to connect to that source of meaning and purpose, even when we're doing training. Changing the way we message about training so that we're not, positioning it as a way to fill time, maybe when employees are furloughed, or as something you do if you want to, but it's not really going to help you out here. The way we frame the training has a huge impact on how seriously people take it. And so, there's a lot of strategies that we can discuss going forward and how to do this, but some of what we need to tap into is this really deep knowledge base we have now on how to engage learners and keep the training designed in such a way that helps people make an individual connection with it, helps them internalize it a little bit more. So I'm really hopeful that that's a discussion we can keep having. And I do think that's another area where the Smart Factory Institute and the partnership we have with them, we can really help to provide some meaningful resources along these lines.
That leads into our next two questions. I'm going to put them together because I think you can speak to both of them. And I would like to get a response both from you, Mary Beth, from an industry standpoint, and then also from you, Dr. Cunningham, from an academic standpoint. The first part of the question is, what college majors do you see contributing the most to these technologies? And I know we're going to go into depth on this next week, but if you can comment on that. And then the second part is degrees versus credentials. What do you see as being more relevant?
Okay, so I'll start off and then hand it to you, Dr. Cunningham. Obviously, degrees that are in computer and engineering related fields will be most relevant, especially as we move into the future. And being able to have a combination of future careers that draw on the engineering type of disciplines as well as the computer disciplines are going to be very, very important, because we're having these interconnected systems now. We don't have discrete differences between the different disciplines like we have had in the past. I think that also when we talk about the workforce, I think what we're going to see is a trend more towards credentials and being able to customize training for the specific job that workers are doing. Another thing I'd just like to emphasize is that training and that credentialing is going to continue throughout an employee's career. It's not going to be a one-time, you get a degree or you get a credential and then you're done, because technology is evolving and it's going to continue to evolve at a very rapid pace. So people are going to have to continuously learn to keep up with that technology for their jobs. Dr. Cunningham?
Yeah, those are great points. And I think what I'm about to say is not necessarily going to change anything that you just said there, Mary Beth, but I do want to maybe highlight on that a little bit. Really, what we call degrees today, if you step back and look at what they are, is that they are structured progressions of courses that are supposed to result in somebody being knowledgeable. But most degrees don't necessarily include a component that guarantees that you'll be skilled or able or competent even necessarily. So even though I am a professor and even though I run a graduate program, we actually, the way we approach it is we've actually kind of minimized the degree language, and we focus on developing competencies now. And along those lines, I'm seeing this trend in a lot of other industries that I work in as well. And this is where that credentialing concept is really probably kind of the approach that we might want to be looking at here, is that when you take a credentialing approach, a degree could be part of what contributes to that. But also there's a need to identify and then develop and maintain competence in particular areas that are relevant for whatever the general domain of work is that you're doing in a manufacturing sector. So this, again, building on a point that Mary Beth just mentioned, is I might be looking for a recent high school or college graduate who is technologically proficient, if I'm going to use competency-related language. But I acknowledge that at the time of hire, they're proficient, but they may not be considered masters, of this area. But that's okay, because if they're proficient, that means I can bring them into my organization and I can start to train them on the particular types of technology we have, on the workflow that we follow. And then hopefully within a pretty short period of time, because they came in with a level of proficiency, within a short period of time with our training in our organization, they can become masters of how this competency needs to be demonstrated in our organization today. So again, the point I would emphasize here is that a degree is definitely part of the equation for some of these areas, but focusing more and kind of breaking down these jobs into what are the key competencies, what are the key knowledge, skill, and ability requirements that we have, understanding that we need to be thinking about the future more than we need to be modeling jobs around what we've done over the past 20 years. This is going to change the way that we recruit talent. And also could be really great for us in some ways, because when you think about this reality that we're going to bring in talent that's proficient and then help them develop and grow so that they can grow with us as an organization, that potentially opens the door to some other pools of talent that we might not have been considering before.
Okay.
All right, great. And I think that Dr. Cunningham leads right into our next question. You've commented a little bit on it, but this comes from a little bit of a different direction. And for the emergent workforce, students are coming in with different capabilities, and then from the incumbent workforce, employees arrive on site, and they also have different capabilities and readiness. Can you talk a little bit about the credentialing, the competency, and the mastering with the knowledge that students and employees arrive at different levels?
Yeah. I mean, this is very much related to some of what I was trying to emphasize there, and I think actually, this is kind of a neat extension of some of the technology that we've been discussing. I know the way that we presented it in the session today was really about how these advanced technologies would support manufacturing processes, and we even talked about the importance of supply chain alignment and efficiency. But it's not a huge leap to extend that same logic to the workforce as an aspect of your supply chain, right? And the technologies you can also extend to your workforce. And we start thinking about how it's possible through the use of certain types of competency-based assessments and screening diagnostic tools to figure out where are these candidates, not for the purpose of screening them out necessarily, but more for the purpose of how do I facilitate your ongoing development and the creation of mastery in you post-hire. And we're actually seeing this happen again across the board because in every industry now, companies are really strapped for talent. So the goal isn't so much now to screen out talent up front, but the goal is now to figure out, well how do we know where you are and where you're weak and where you're strong? And then what do we do about it? And so these technologies that we're using now to create new efficiencies in production can also be used to create new efficiencies in personalized or at least semi-personalized training and development trajectories, curriculum plans that are administered using technology. We can also make use of simulations and other types of advanced tech to help these individuals develop a sense of mastery, a sense of competence, and a sense of confidence that they can then take these knowledge and skills and abilities and competencies and put them into practice in the production environment. So I'm actually very hopeful that these technologies will not just benefit our productivity in this industry, but I think they're actually going to be able to be leveraged to benefit the workforce as a whole.
All right, thank you.
Mhm.
And then the interesting add-on question for this is taking us back to the K through 12 is what do you see as the role for after-school programs?
So I'll again talk on that. There are a lot of opportunities for students to get involved in after-school programs, either through the schools or independent organizations. Last Saturday, there was just the Lego League competitions here at Volkswagen Academy. And that's an opportunity to introduce STEM careers and opportunities at a young age that is fun and interesting and gets kids involved in wanting to learn more about technology. I think those after-school programs will be increasingly important to support education. Uh, Dr. Cunningham?
Oh, I totally agree. I mean, I have two young sons myself, and any opportunity they get to get involved with those types of hands-on learning experiences is huge. Unfortunately, any of us that have kids know that the last couple of years, a lot of these opportunities have been really impeded by COVID-related restrictions, and we can be hopeful that this will come back, this will bounce back. The thing that I think we could really, if we wanted to up the game here a little bit, one of the areas where these programs sometimes fall short of their potential is that they're not always supported with close partnership by actual manufacturing organizations. And that's a huge missed opportunities because these types of experiences are not just designed to give kids an opportunity to see what is this skill that I need, or what does this process look like in general. We'd really like to be able to give them a complete and more realistic perspective on what would it be like if this was a big part of my job. Like if I got to do this every day and I actually had to be paid for this and receive benefits for doing this kind of work. And I did this with other people who like to do this. What would that be like? And kids can't possibly know that unless we give them a chance to see how this works on a larger scale. So definitely would encourage, organizations where they have the capacity and the opportunity to partner with their schools in their communities and give these after-school programs a chance to extend beyond just a little mini demonstration. That's when these become very memorable experiences and can actually change a student's entire career trajectory.
Yeah, and I would just echo that point. Manufacturers really do need to get involved, and there are a lot of opportunities to get involved. I know from my experience in manufacturing, we often were asked if we could partner with a local school to work on, help provide a project for their STEM students to work on, or provide tours of our manufacturing facilities, or even go help with classes in talking about technologies and what our operations were. So I would encourage manufacturers to participate. Any other questions?
Yes, we do have another question, and that is, and I know that Dr. Cunningham, you and Scott have done some research. I know that there's not a lot of examples, but the question is can you share examples of how companies are rewarding and measuring mastery?
Yeah, you're right. And we expect to see, more best practices and examples of this being shared as more companies adopt this sort of competency based focus on talent management. But I can tell you from some experiences that I've had, and I'll admit, not all of these are just within manufacturing, but I think they generalize quite well. Obviously there's opportunities to reward mastery with, increases in pay or new benefits. But sometimes what's important to understand is that people that pursue mastery and have a real strong sort of need for achievement also are people that have aspirations to continue to develop their careers. And so one of the ways that we often forget to reward mastery is offering opportunities for job enrichment or job enlargement, allowing individuals to expand their role, to expand their influence. I'm not suggesting that everybody who achieves mastery needs to necessarily be promoted to manager, because that's an entirely different set of competencies. And so that's not the argument here. But sometimes individuals they start in a very narrowly defined role. And then when they master that, it can become very boring and stagnant very fast. And so thinking about ways that we can add elements to that role or help individuals feel that they have an opportunity to craft or innovate a little bit, maybe with how they tackle the work in that role. Those can be really good strategies. The other thing that many companies do is they identify folks who demonstrate mastery, and they kind of give them an opportunity to share that mastery with others. And so I'm sure some of the folks with us today even have developed on-the-job trainer or mentor type processes where they recognize those who are masters, and these individuals then help to lift up the competence of the entire workforce. That is actually a very effective strategy for some people. I think the only general thing I'll say here, without turning this into a huge tangent, is that when it comes to reward strategies in general, it's never going to be the case that one strategy is going to work equally well for all people. So I think it's really important, if we want to get serious about encouraging people to continue their development and to develop and maintain and sustain mastery, we need to understand what our folks value. And so some of them would value being respected by their peers. Some of them would value having the opportunity to do a little bit more that's challenging. Some would value access to more advanced training because maybe they want to advance that career. Some would value a little extra pay. So having a few different options to pull from, and then doing this in consultation with the individual, is likely to optimize the value of that reward.
Okay, very good. Okay, let's move into our next poll. So again, we're going to poll the audience and ask, what challenges are you having in developing and or implementing your smart factory roadmap? And choose all that apply. Is it cost investment, lack of skill, expertise, uncertain results, or uncertainty with the return on investment? Is it a concern about being able to keep up with changing technology, making sure that once you invest into that technology, it is still relevant? cybersecurity, or are there other concerns? So the results are coming in, and it looks like we're seeing that most of our respondents are very concerned about the cost and the investment. And that is consistent with what we have seen in past polls. Manufacturers want to make sure that they're spending their money wisely, and they want to make sure if they're investing that they do get that return on investment. But then there's also a concern very clearly about lack of skills and expertise, and that could be skills and expertise in defining and implementing that new technology, as well as skills and expertise in operations.
Mary Beth, we've had a question come in that said data security is limiting many manufacturers. Can you please discuss?
Yeah, data security is a big concern, and even though it wasn't one of the top 3 in our survey, we've all heard about different companies that have been subject to cyber attacks and that have had operations completely disrupted. One of the things that is emerging is an increased focus and emphasis on cybersecurity. And what I would say is that that is actually one of our topics coming up in our Robotics Congress on March 3rd. We have a session entirely focusing on cybersecurity in manufacturing. Dr. Cunningham, would you like to add anything?
I think that is a big topic for future discussion.
Yep. Okay, so that leads me to a discussion about the upcoming sessions. Is your workforce ready for the changes that are coming with Industry 4.0? Come join us for session 2. February 9th, same time, next Wednesday. We'll be live streaming again from Smart Factory Institute in Chattanooga, and we'll talk about the Smart Factory Worker of the Future and opportunities to upskill and reskill incumbent and emergent workers. And then also register for our February 16th, session 3, where we'll be discussing how to leverage organizational resources to achieve an Industry 4.0 return on investment. That one will be in Smyrna, and you will have the opportunity to either attend live or virtually.
And Mary Beth and Dr. Cunningham, we have one last question that we have time to take. I know most of this will probably be covered next week, but it is asking about speaking from the perspective of the already established older members of the workforce. And as we're looking at training, and maybe this is just a tee up or a teaser for next week, but if you had any quick comments on that in the last minute or two that we have.
I'll let Dr. Cunningham comment on that one.
Yeah, sure. So I think this is the question I saw from David, and this is a great question. And I'll start by addressing the last part, which is whether, it may not be ideal, but is it doable? I would say that it's necessary. You might recall earlier in the presentation that there's a rather large gap in terms of workforce needs, and also the supply itself is declining. So there's no question that we need to figure out how to engage the members of our existing workforces just as badly as we need to figure out how to engage the emerging folks. The challenge is that there probably will be significant portions of our existing workforce that really don't have an interest in retooling and reskilling and upskilling. And I think that we're going to have to figure out some strategies for dealing with that. The good news is this transition, this training is not going to happen overnight. And it's not going to be the case that everybody's jobs are just going to be morphed or adjusted. It's also not going to be the case that these jobs are just going to disappear. A lot of these jobs are adjusting and they're being tweaked. And so some of what probably will need to happen with the existing workforce is some long-term communication and clear messaging about transitions that are coming up. If and when your organization decides to make an investment in technology, that's going to be a rather major organizational change. Just like any other kind of organizational development activity, there's going to be a need to figure out how ready is our workforce for this change? How do we communicate the message for change? How do we help these individuals get on board with it? So the specifics are going to really depend on your unique situation, but it is something that's doable. It is something that's necessary. It may not work equally well for every single member of that existing workforce, but we do have to understand that there will be significant portions of people that they want to keep working for that organization, and they know that times are changing, technology is changing, and if you're able to help kind of hold their hand and guide them down that process, this might actually go a long way toward keeping them committed, keeping them engaged with your organization. So definitely don't give up hope on it, but definitely need to get serious about how this is all communicated and managed.
Okay, good. So again, join us for the next series of transformation of manufacturing sessions. And also, I would invite you to mark your calendars and join us for the series of 7 signature Smart Factory Institute events that we have scheduled throughout the year, starting with the Robotics Congress that I mentioned in March and going through December with another intense follow-up on workforce. One of the ways that you can engage in attending all of these series and partnering with the Smart Factory Institute is through our Smart Factory Institute Manufacturer Circle. We're offering packages that include tickets to each of our 7 signature events. Also, it comes with an in-person industrial automation assessment to help identify opportunities to improve operations, and access to our online Peak Workforce Training Center, and also registrations for online smart manufacturing training courses. So you can join as a group or an individual, and we would love to have you partner with us at the Smart Factory Institute in Chattanooga. And again, thank you for attending today's session. You can download the report by scanning this QR code, and also register for the next 2 sessions through this link. And I thank you again for joining us.
All right, thank you, and we're turning that back to you, Susie. Or maybe we're not turning it back to Susie. So thank you, everybody, for attending. We appreciate it, and hope to see you next week.
Thank you.